Hey everyone, this is Mrs. Slauson, one of the Algebra 2 teachers, and I am going over ICANN number 13, first attempt. If you are in my Algebra 2 class, then your due date is listed above. It's November 10th, which is going to be a Thursday. If you are in Miss Hampton's Algebra 2 class, then hopefully your guest teacher has told you when that due date is going to be. Otherwise, let's go ahead and get started. So we are going to be going over ICANN 13 first attempt, and this covers a little bit from chapter 2 and then also the first part of chapter 3, 3.1. So what we're going to be going over is composition functions and then inverses. So the idea of composition functions first started in chapter 2 at the very end. So let's go ahead and get started. We have our three functions. We have f of x. So here we go. We have g of x. And then we have h of x. So let's take a look at our first function. In this first function, f of g of x, what this is telling us to do is that we are supposed to take g's function and put it into f's function. So literally, this function is going to be going over here into f's function. So the first way I could get this started is just by replacing this g of x with what g of x is worth. And then this is saying the same thing that I just already said, that in f's function, I need to put x squared plus 4. So where the x is going to be replaced, and I'll put in x squared plus 4. There is still the plus 6. And whenever you substitute something in, always put it in parentheses. Sometimes you need the parentheses, sometimes you don't, which is this case, I don't really need the parentheses. So I can drop them and just combine my like terms of 4 and 6 to get 10. So when I'm done, f of g of x is worth x squared plus 10. And then this is my final answer for number 1. All right, so for number 2, what I'm going to do is erase my functions. It takes, this pen is very temperamental, so sometimes takes a while to erase. And in this one, what I'm supposed to do is I've got a lot of things going on. So in this problem, if I just want you to focus on those outer parentheses, I'm going to start with f of x and just focusing on this. And this says I should go to f's function. So here's f's function. And in f's function, I should take this 4 and put it in there. So that's what I'm going to do. Instead of x plus 6, I'm going to change the x into 4 plus 6, so I get 10. So as it turns out, f of 4 is worth 10. So basically what happens is I can get rid of this f of 4 and replace it with the 10. So then my problem becomes this. H of 10, and now this says go to h's function, so here's h's function, and in for x, I should put that 10, so that's what I'm going to do next. And again, anytime I substitute something in, I'm going to put it in parentheses, so this just becomes 20, take away 5, my answer is 15. So when I take h of f of 4, I get a final amount of 15. So 3 and 4 are going to be similar. I don't know why there isn't as much room here. I apologize for that. But let's go ahead and get started. So in this set, we're going to be working with our two functions. So let me go to the top and just do some erasing. So we're going to be working with f of x. Oh, and we're going to be working with g of x again. And this time we're just going to switch it. So according to this says f, I'm going to write over here, should go into g's function. So f is literally going to go in here right where that x is. So the other way I can set this up is replace the f of x with what it's worth, which is this. And then this says the same thing. I should go to g's function and put x plus 6 in there. So I don't have a lot of room, so I'm going to switch colors on you. And then I'm going to put it in blue and then let you guys, I'm going to move up here. So instead of x being squared, now what I'm going to do is I'm going to have x plus 6 squared. And your job is to get this so as there's very few parentheses as possible, which means we're going to go back to something that we did in ICANN number 6 and realize that there's 2 of these x plus 6's that we're going to multiply or distribute, or as in my class, I call them the neighbors meet the neighbors. So let's go and have x distribute or meet the neighbors, and I get x squared plus 6x. And then the 6 can distribute, or the neighbors meet the neighbors. I get another 6x plus 36. So when I add those up, I get this. I don't want to forget about the plus 4 that's there. So when I'm done, g of f of x is going to be x squared plus 12x plus 40. All right, my very last problem says I should only be working with f of x. So I don't have a lot of room, again, but let me rewrite the problem here. So in a situation like this, we're putting a number again into a function. So just to show you, I want you to focus on these outer parentheses and just look inside them. And this says that we should go to f's function. So that's what I'm going to do. Let me erase up here. So I'm going to go to f's function, and I should take 1 and put it into f's function. So if f's function is this, I'm now going to put the 1 in, and I get 7. So basically f of 1 is 7. So this whole thing turns into 7, and now this is the function we're working with. And this says go back to f's function, which again is this, and this time put 7 in, and when I do, I get 13. And so my final answer is f of 1 is 13. And you could also just squish it in there too if you want, but that's the work that goes with it. All right, number 5, the following are inverses, and we're going to verify that they're inverses by using composition functions. So what you should have learned is that if you take the composition of these, so there's one situation and here's the other situation, that when you're done, you should, after you simplify them all out, so try to get rid of all parentheses and stuff, get x as a solution for both of them. So that's what we're going to do. Again, I don't have a ton of room, so I think where I'm going to work for problem 5, I apologize for the lack of room, is I'm just going to try to squish it into here as best I can. So the first one I'm going to do is f of g of x. So again, all this is saying is that g should go into f's function. So g, I'm going to circle it, should go into f's function right there. The more mathematical way to write it is replace the g of x with what it's worth. And then this says the same thing. I should go to f's function and put in that square root of x minus 4. So that's what I'm going to do. So instead of x squared plus 4, I'm going to get rid of the x, put this in there. Remember, I'm putting it in parentheses, and now that will be squared plus 4. So hopefully what you remembered or realized from your chapters is that if you square something that's being square rooted, those things just cancel each other out. So you're just actually left with x minus 4. Then there's the plus 4, and now these 4's can cancel out, so I just get x. So I'm off to a good start. When I did f of g of x, I got x, and I'm good there. So let's look at the other scenario. So in the other scenario, what's going to happen is I should do g of f of x, which again just means that I should take f's function and put it into g's function. So going back to up the top where this problem exists, so let me do a little erasing. F's function should go there now. The more mathematical way is to go back to the function notation, replace f of x with what it's worth, and then this is saying the same thing. Go to g's function, so I'm going there, and put x squared plus 4 in there. So if this is g's function, where that x is where I'm going to put my stuff in there. And again, I'm going to put it in parentheses. These parentheses aren't actually needed. They're not doing anything, so I'm going to drop them. And what I'm going to notice first is this time my 4's will cancel out first. And then just like before, that square root and that squared will cancel each other out, so we just get x. So one thing to notice is the way I eliminated things is the exact opposite between the two. So in this first scenario, which I'm going to box here, I got rid of my exponent and squared first and got rid of my 4 second. In the other scenario, so let's change colors over here, this time I got rid of my 4's first and my square and square root last. So they just switched. That's kind of like a different inverse. All right, last part for this video, I'm going to find the inverse. So finding the inverse means we will use inverse operations to rewrite this equation. So the first thing you have to remember is that f of x is just y. And the second thing we're going to do is then start the inverses. So x becomes y and y becomes x. Because we're going to be writing a function, all functions are y equals, or in this case, f of x equals. So we're going to have to rewrite this equation so that this y where it is going to be by itself. So the first thing I'm going to do to get y by itself is subtract 7. And so the left side still has 3y, and the right side is x minus 7. I'm just going to write it left to right instead of top to bottom. And then the next thing I'm going to do is to get y by itself is divide by 3. And I'm just going to divide each thing over here by 3. These cancel out, and when I'm done, I get y equals x over 3, which is just 1/3 x minus 7/3. And don't worry about the fractions, that's okay. To show finally that you have your inverse function, make sure you use inverse notation, which looks like this, and then just repeat your answer. All right, the next problem, same thing. You first need to realize that g of x is just y. And then the first step of inverse is to make y become x and x become y. And now I'm going to work to get this y by itself. So the first thing I'm going to undo is the addition subtraction. I'm going to subtract 3. So my left side, I'm going to drop way down, is now x minus 3, just written left to right instead of up and down. And then from there, I'm going to move the 2 by dividing by 2. And you can just divide again each thing by 2, no problem. This x over 2 is just 1/2 x. Minus 3/2 is actually, you could just leave it like that. If you want to turn it into the decimal, you can. And now the last thing I'm going to get rid of is the squared. So to undo the squared, I'm going to square root, and then I'm going to square root all of this. So I just want to make sure that all of that ends up under the check mark. So when I'm done, and now that I have my inverse notation, is y, I'll write it as inverse notation of the function. And that is ICANN 13. Now, don't forget spiraling. So let's check out our spiraling. The first thing we're going to do is graphing. So since I see the cubed, I got to remember the points I'm using here are -2, -1, 0, 1, and 2. And to get the y values, I will actually cube those x values to get the following numbers. So this is a review. Let's talk about the transformations. So this is our stretch. This is going to say right 4, and this is going to say up 1. So the first thing I'm going to do is apply my stretch, and I'm going to multiply all of these by 2. And I'm going to get -16, -2, 0, 2, and 16. Now the 16s won't fit on the graph, but hopefully we remember that that's the shape. So anyway, I'm going to be going to -1, -2, and I won't stay there. I'm now going to go right 4, 1, 2, 3, 4, and up, how many? 1. So I end up right there. And then I'll go to 0, 0, and go right 4, up 1. And then I'll go to 1, 2, and go right 4, up 1. And then that's it. You just have to remember the shape so that you can get it graphed. All right, last question. We are going to solve for f of x equals 17. This is the same as y is 17, which y being 17 is way up here above the graph. So instead what I'm going to do is set my equation equal to 17 and start solving. Because this is just one type of x, I'm just going to get x alone. So the first thing I'm going to do is subtract my 1, which gives me 16. The next thing is I'm going to divide by 2, which gives me 8. And now what I'm going to do to isolate x is I'm going to cube root both sides, which leaves me with x minus 4 on the left and 2 on the right. And then my last step to get x by itself is add 4, so my answer is 6. So my answer, if I want to write it technically the correct way, my function, if I make x become 6, is 17. And if I go to my graph, if I go over 6, is it possible that it could be 17 way up here? Absolutely. That's definitely a good possibility. And that is it. If you're in my class, I am going to ask that you hold on to this until Thursday, November 10th. See you later. Bye.